Ketone bodies stimulate chaperone-mediated autophagy. Chaperone-mediated autophagy, CMA, is a selective lysosomal protein degradative process that is activated in higher organisms under conditions of prolonged starvation and in cell culture by the removal of serum. Ketone bodies are comprised of three compounds, beta-hydroxybutyrate, acetosidate, and acetone, that circulate during starvation, especially during prolonged starvation. Here we have investigated the hypothesis that ketone bodies induce CMA. We found that physiological concentrations of beta-hydroxybutyrate, BO, induced proteolysis in cells maintained in media with serum and without serum. However, acetosidate only induced proteolysis in cells maintained in media with serum. Lysosomes isolated from BO-treated cells displayed an increased ability to degrade both glyceraldehyde 3-phosphate dehydrogenase and ribonuclease A, substrates for CMA. Isolated lysosomes from cells maintained in media without serum also demonstrated an increased ability to degrade glyceraldehyde 3-phosphate dehydrogenase and ribonuclease A when the reaction was supplemented with BO. Such treatment did not affect the levels of lysosome-associated membrane protein 2 or lysosomal heat shock cognate protein of 70 kDa, two rate-limiting proteins in CMA. However, pretreatment of glyceraldehyde 3-phosphate and ribonuclease A with BO increased their rate of degradation by isolated lysosomes. Lysosomes pretreated with BO showed no increase in proteolysis, suggesting that BO acts on the substrates to increase their rates of proteolysis. Using oxyblot analysis to detect carbonyl formation on proteins, one common marker of protein oxidation, we showed that treatment of substrates with BO increased their oxidation. Neither glycerol, another compound that increases in circulation during prolonged starvation, nor butanol or butanone, compounds closely related to BO, had an effect on CMA. The induction of CMA by ketone bodies may provide an important physiological mechanism for the activation of CMA during prolonged starvation.